In this video we have problem 2 in this series, and we're looking at, again, in general, integration techniques. Take a look at this one, decide which method you would use, and then see if you can solve it, and then I'll be back. Probably the majority of the time when you have a integration of a natural log and some factor of x, whether it's times x or divided by x to a power, chances are it's going to be an integration by parts. So here we have the two functions we can look at is natural log of 2x and 1 over x squared. So we have to pick our u and our dv, and we pick dv for ln of 2x for dv. Then we're going to integrate this, and there is a formula for that, but it can get a little bit tedious. So what we'll do here, and again, I'm not going to use the abbreviated form of integration by parts because this one is not that bad. I'm just going to let u equal to ln. That can easily be differentiated. So u equal to ln of 2x. So du would be the derivative of this, which would be 1 over the expression there, 2x, and then using the chain rule, the derivative of 2x, which would be 2. And here we're going to assume that x is positive, so we can avoid absolute values here. This is a dx here, so the 2's cancel out, so I get 1 over x. And then we'll let dv equal to 1 over x squared. That's fairly easy to integrate, and that's what you want. You want to pick u. You want to pick something for u that's easy to differentiate, and something for dv that you can easily integrate. So I'll write this as x to the negative 2, and then take the antiderivative of this. This will be v then equal to, add 1 to the exponent there, general power rule for integrals. That'll be a negative 1. And then divide the coefficient by negative 1. This will be a negative here. And then the general formula for this integration by parts has the first part is just the product of u and v. So there's u and there's v over here. So multiply those out. This will be minus, I put the x to the negative 1 in front, and then I put the u next. That's uv or vu. This will be ln of 2x. And then it's minus the integral of v du. So there's v that has a minus x to the negative 1. And that's going to be times du. And du is this right here. So that'll give me times 1 over x dx. Now we continue with this. Minus x to the negative 1. ln of 2x. And then we have a double negative here, so let's make this a plus. And then we're going to have the integral of, bringing this up to the numerator, that'll be x to the negative 1. So this will give me x to the negative 1 times x to the negative 1 is x to the negative 2. And then we can easily integrate this with respect to x. So again, this is equal to minus x to the negative 1 ln of 2x. And then we integrate this one. Again, general power rule for integrals, add 1 to the exponent there. That'll give me x to the negative 1. And we divide the coefficient by negative 1. That'll make this a minus here. And this will be plus the constant of integration. And that's pretty much it there. We could factor out a negative x to the negative 1. Don't have to. But again, if you're working problems from the textbook with answers and your answer doesn't match the textbook, sometimes they'll simplify it or factor it out. So if I take out a minus x to the negative 1, your answer might look like this: ln of 2x plus 1. And then you got your constant of integration. Again, this is a series of miscellaneous integrals that I selected to make videos. Again, just demonstrating some of the techniques, and some of these I've already covered in other videos, but I'm trying to mix it up a little bit here. So this is the answer to this one here. Coming up with another video later. Thanks for watching. We'll see you next time.